He has worked with multiple products and is an embedded engineer graduate who's having a decade of experience in embedded hardware, board design, engineering, and IoT solution. Served in leadership positions for automation projects with several industry and institution, and have given a lot of institute and events, like by giving guest lectures in various colleges and university as well. With further ado, I just want to hand over the session to our speaker, Mr. Sabarinath Premlal. Please take over the session, sir.
Yeah, thank you, ma'am. Okay, thank you for your support. And so today I'll be explaining about that object recognition in the morning session, and in the evening I'll be connecting with the pattern recognition. Okay, so I'll be explaining in detail about the object recognition. Okay, so then I'll explain about the pattern. And also I'll be connecting with different use cases where we can kickstart and initiate the business cases. So all these steps I will be explaining today. Okay. So if you're having doubt, please feel free to connect us. Okay. So now I'll share my screen. Yeah, I think the screen is visible to everyone.
Yes, sir.
Yeah. So I am starting with the object recognition. So by basic, if I'm connecting with the object recognition, okay, mostly this purely works under the deep learning mechanism. Okay, so connecting with the SVM algorithm, bag of words model, okay, Viola-Jones algorithm. So different algorithms are there. Okay, based on that, okay, this object recognition. So today we will be seeing about the CNN algo also, and also some algorithm methodologies, and also we will try to connect in a different way. Okay, how this object recognition works. Okay, so if I'm kickstarting with the object recognition, practically we can say the object recognition is a technique where the computer vision technique for identifying objects in image or videos, whereas the object recognition practically is a key output of deep learning and ML algo. When human look a photograph or watch a video, we can readily spot some people, object, scenes, and also some visual details also. Practically, the goal is to teach a computer to do what comes naturally to the humans to gain a level of understanding of what an image contains. Okay, so this is how our object recognition works. Even it has a key technology behind the driverless car, enabling them to recognize stop sign or distinguish a pedestrian from a lamppost. Okay, it is also useful in a variety of applications such as disease identification, bioimaging, industrial inspection, and robotic vision also. Okay, but there is a big difference between object recognition and object detection. Okay, both object detection and object recognition are a similar technique for identifying the object, but they vary in their execution actually. Okay, practically the object detection is the process of finding the instance of object in images. In the case of deep learning, the object detection is a subset of object recognition. Okay, whereas the object is not only identifying but also locating an image. This can allow the multiple objects to be identified and located within the same image. So that's what the object recognition, that's what the object detection is playing a big role. Okay, even the techniques via the ML and DL have become a popular approach to object recognition problem. Both the techniques learn to identify object in the image, but they differ in the execution practically. Okay, even if I'm connecting the ML based, so we'll be having some labeled data and connecting to the manual extraction. Okay, so we are connecting with the classification algo via the ML process, then we are classifying it. Whereas if I'm connecting with deep learning, everything is connecting with the neural networks. Okay, based on the neural network only, it acts accordingly. Okay, even the deep learning, such as a CNN model, are also used to automatically learn an object and inherit the features in order to identify that object also. For example, we can say CNN can learn to identify the difference between, let's assume the cat and dog by analyzing thousands of trained images and learning the features that makes the cat and dog are different. Okay, so there is a two different approaches we can able to connect. Okay, one is training a model from scratch. Okay, to train a deep network from scratch, you gather a very large labeled data set and design a network architecture that will learn the feature and build the model. The result can be impressive, but this approach requires a large amount of training data, and you need to set up the layer and wait in the CNN. Okay, whereas using a pre-trained deep learning model, okay, the most DL application use the transfer learning approaches, a process that involves a fine-tuning a pre-trained model. You start with the existing network such as AlexNet, GoogleNet, and feed in the new data containing the previously unknown cases. This method is less time consuming and can provide a faster outcome because the model has already been trained on thousands of millions of images. Okay, so practically the deep learning offers a high level of accuracy but requires a large amount of data to make accurate prediction. Okay, so this is while we are connecting with the deep learning, whereas if we are connecting with the ML, okay, so this is a generic methodologies. Okay, the object recognition and offer different approaches than deep learning. Okay, so a few minutes back I said, right, SVM ML model. Okay, the hog feature extraction. Okay, bag of words model, feature as surf and MSCR. Okay, Violana-Jones algorithm, which can be used to recognize a variety of objects, including the faces and upper body, everything we can. To perform object recognition using a standard machine learning, you can start with a collection of images or video and select the relevant features in the each images. For example, I can say the feature extraction algorithm might extract the edges or corner features can be used to differentiate between classes in the data which is present. Okay, like that also we can initiate it. Okay, these features are added to a machine learning model which will separate these features into a distinct categories, then use the information when analyzing or classifying the new object. You can use a variety of ML algo and feature extraction method, which offers some many contribution to create an accurate image recognition model. If we are going to train the data, okay, let's assume we'll be having three different parts. Three different images, image on image to image. Three different objects, object on object to object three. So feature extraction can be done. Then ML model classification has to be done such a way that we need to connect the test data, and even I'll show those demos also to you. Okay, by using the ML for object recognition offers a flexibility to choose the best combination of features and classification of learning. Even this can achieve the accurate result in the minimal data. Okay, whereas determining the best approach for object recognition depends on your application and the problem you are trying to solve. In many cases, I can say the ML can be an effective technique, okay, especially if you know which feature or characteristics of images are best ones to use to differentiate a class of the objects. The main consideration to keep in mind when choosing between the ML and DL is whether we have a powerful GPU and lots of labeled trained images. If the answer to either of these questions is no, practically a ML approach might be the best choice. Okay, because deep learning techniques tend to work better with the more images, and GPU helps to decrease the time need to train the model. Okay, here you need a good hardware, lots of data. If it is yes, go ahead for DL. Else, go ahead for ML. Okay, so even we can connect with different object recognition methods like uh, template matching, which uses a small images or template to find the matching regions in a larger image. Also, like this, also you can use image segmentation and blob analysis, which uses the simple properties such as the size, color, and shape. Typically, if an object can be recognized using a simple approach like image segmentation, it's best to start by using the simple approach. This can provide a robust solution that does not require hundreds or thousands of images or an overly complicated solution. Okay, even you can use the MATLAB. Okay, you can use Python. The environment can be anything, but objective is a bit different. Okay, yeah, you can connect with any environment. Okay, so even if you are connecting the GitHub, the lots of codes are available. So no, the one and only thing is we need to choose the right code and kickstart it. That's it. Okay. So here I'm just showing some images. Okay. So in these things, so I'll be connecting the images with the feature detector. Okay. And corresponding with that feature detector, I'll be connecting the necessary features. Okay. So I'll be concentrating on the hypothesis formation. Okay. In this hypothesis formation, okay. So I'll be having a predefined model. Okay, model base. So I'll be connecting with the model base and connecting with the test data. So such a way that this hypothesis verification can be done. So corresponding the object class can be triggered or initiated. So likewise, this process is done. So better I'll give a demo, then I'll continue with the next slide. Because if I start giving the demo, your understanding level might be different. So this is the demo that I'm connecting in most of the cases. So now I'll give that demo. So if you're searching the Google Teacher Mission, you can able to get this link. So I'm going to connect with the image processing. Yeah. So I'll be connecting with that image processing. So 1 minute. So I'll take some development notes. 1 minute. Please be in the line. So this is a generic example. Whenever I'm connecting to the DL or ML, so this is the generic example that I'm giving to most of the people, and I'm showcasing those examples to the most of the people. So the same example now I'm going to connect. So the thing why I'm trying to do this is this is it's easy to understand. That's it, nothing else. Okay. So this works based on the CNN algorithm. Okay. So I just initiate here. We are having a different classes. So this is nothing but a labeling the data set. So now I'm going to label it with the different development board that I'm having. So I'm having a different development board. Pre scale board. So I'm going to take the real-time images. So I think I'm visible. Okay. So I'm going to take some sample images of different development boards like this, like this, like this. Okay, so at least 6 to 7 classes. Okay, so here I'm showing those. So now I'm going to record it. So I took 76 images in the front side, and also so I took around 120 images. Okay, so my first sample is ready. This is purely a data set. This is purely a data set, and which is under the label called free scale. Which is under the label called free scale for this development board. So now I'm going to take the next development board, uh, MediaTek processor. So here I'm having that MediaTek processor development board. So I'll be connecting with this development board. The backside also I'm going to take. So around here also around 150 images approximately. Okay. So I took two different development boards. So I'm going to add one more class. So Azure. As the development board. So I'm opening my webcam. So this is from Avnet. Okay. So this is especially used for Microsoft Azure. So I took 100 images. So I'll add the RNSS board. Yeah. I'm taking the sample of the RNSS board also. So here also I took 100 images. Okay, then I'll add two more classes. One is the generic board that everyone knows, that Raspberry Pi. So I'm going to use Raspberry Pi. So I took 100 plus images. So finally, the, the development board known by the most of the people called Arduino. So I took around 120 images. So totally I'm having some different classes. So 800 plus images. Okay. So I'm going to train this model. I'm going to train this model. Here I'm going to click the train. So here you can able to see the different image samples. Okay. Under with some labels. So I'm going to train this model. Once I click the training, so it really works in the cloud, right? So practically it will take some delay. So we need to wait for the delay. Okay, this is purely based on the internet speed. So around the 700 images are all considered, and it should be connected to the cloud. Yeah, that's what it's getting trained. Okay. So once it is completed, okay, we can able to connect with the output. Okay. This is purely under the classification process. Yeah. Now This shows me as a Arduino. Without showing anything, this considers me as a Arduino. Okay. Even I can able to answer it why this happened. The thing is, in all the data set, I took the images of this board only, but whereas in the final Arduino only, okay, I shown my faces clearly. In most of the data set, I shown my faces clearly. Whereas in this Renesas also 1, 2, 3, some around 5 or 6 images I shown. Okay. Like that. Whereas if I'm showing the board like this, practically it recognizes as Renesas. Okay. If I'm showing some other color board, like green, okay, it identifies the MediaTek also, but partially it identifies it's something like Arduino, and whereas slightly in the Renesas. So it based on the pattern. So if I'm showing the board like this, practically it identifies. So this is nothing but a MediaTek processor, and also if I'm showing, this is purely a Freescale one. So if I'm showing this, so this is purely a Azure. So if I'm showing the Raspberry Pi, this identifies the Raspberry Pi also. So the thing is, what I'm trying to say means, okay, I'm connecting a different development boards. Okay, so I took images of each and every development boards. So it is connected to the CNN algo. Okay, based on this CNN algorithm, okay, it identifies under which category, which board it is. So practically it identifies it. So that's it. So the thing is, what I'm trying to say is, okay, the based on this is purely CNN. Okay, if I'm showing the image get recognized. Okay, so once the image get recognized, it acts based on those recognition process. So that's what I'm trying to say. Okay. So I think you understood about these things. Okay, based on the demo, but I will explain in a DL also. This is a purely image segmentation. I mean, based on the image process. Whereas based on the audio is also is there. Okay, even I'll share that demo also now. Okay, so I think you understood about this. So if it is sees, I mean, if I'm showing my face slightly like this, partially it accepts the Renesas. Okay, so then rest of the things are all audio. Okay, so if I mean, let's assume if I'm doing like this, so this is partially identifies the Renesas. So I'm having around only 800 plus images only. So if I'm having 8 lakhs or 10 lakhs of images, the accuracy is very good. Okay, so if you're having a GPU and also the more data, the DL is advisable. If you're not having a GPU or the more data, the ML is advisable. So this purely works with the ML. I mean, this is capable of connecting with the ML and DL. And also the one more advantage in this means no need to program anything. So we just add the labeled data, so that you have to train the labeled data under which category it is. So once it is trained, it automatically identifies. Okay, here you can able to see the export model. Okay, if I'm clicking this, so here I can able to get the necessary coding. So you can able to integrate in your web page or the app. Okay, the thing is, what I'm trying to say is, okay, if you are having the requirement from your startup or business cases, okay, instead of doing all the coding, so 99, not 99, 100% coding is available in the GitHub. The one and only thing is you need to tap and take the GitHub and just do the modification. That's more than enough for you to match your requirement. Okay, instead of spending more time, so you can able to use the solution which is predefined solution, especially that matches the requirement for your projects or to your clients action. I think you got some idea. Okay, now I'll connect to the audio project. Yeah. How this is how this audio project works. So I'll explain these things in detail. Okay. 1 minute. Yeah. So here I'm going to connect to the audio project. So the thing is, I got some notification in my server. So that's what I just barely I'm concentrating my work also. I responded to this. Okay. So here I'm having a different classes, similar thing that is back. Okay. So here I'm going to connect with my mic and I'll repeat some audios continuously. Based on that, I'll get the corresponding audio. So now I'm going to repeat. So I'm going to repeat few words continuously for 20 seconds. So hi, 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 hi. So I'm extracting those sample also. So similarly, in next class I am going to add hello, 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 hello. Sorry, I need to change the settings. Sorry. Hello, 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 hello. So I'm extracting those samples also. So finally I'm going to add one more classes. This is the final class. How are you? 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 I'm extracting this sample also. So I'm going to train the similar procedure what I shown previously. I'm training the same method. So again, it takes based on the internet speed and everything. So if I'm saying hi, 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 you can see in the data visualization that most of it follow the classroom. If I'm saying hello, 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 it falls into the classroom. If I'm saying how are you, how are you, how are you, it falls under the class 3. Okay. So the similar methodology that what we did it in the image processing, this is purely for audio. So even you can able to integrate this in your project like anything. Okay. So the one and only thing is what I'm trying to say is okay. So this is purely methodology where you can and it's not a methodology. This is the basic example where you can able to identify and how it works. So these details you can able to get clearly. So for that cases only, I'm just shown these results. So nothing else. So I think you got it. I mean, what I'm trying to say. Okay. So this is about the demo. So now I will be explaining somewhat about the DL mechanism, then few more algos, and I connect with that presentation also. Okay. So I think we understood about this. So I'm leaving this site. Yeah, I came out from the site. Del DL. Before that, I just explain about the ML also. Yeah. So, so in this ML, okay. So I can give you an basic idea of what is ML it is. Okay. So practically ML is a methodology where the machine can learn or infer from the data. Okay. So we are training the machine such a way that it should accept it. Okay. Yeah, 1 minute please. One minute. Sorry, some external disturbance. Sorry. So, so the machine learning. I mean, if you are connecting with the okay. So initial stage we learn how to ride the cycle. Okay. So the first day you will be focused on right brake, left brake, the pedaling, right pedaling, left pedaling, the hip rotation, the eye concentration, the balancing, everything you'll be focusing at the same time. So practically what you are doing means you'll be doing multiple tasks at the same time. Practically you are under the process of learning how to ride the bicycle. Okay, once you learn those methodologies, practically what happens means, okay, whenever you are riding the bicycle, everything works under your subconscious mind, not in your conscious mind. Everything works under the subconscious mind. So you'll ride peacefully. So this is the way that you will be riding your. So this how that ML training methodology or process will work. Okay. So similar methodology here also we are going to connect. Similar methodology here also we are going to connect it. Okay. So in ML, there is a two different way. One is a superficial. So these things everyone knows. Okay. So the basic exam that I'm giving. So if you are getting your some X marks in your plus 2 examination, HSC examination. So whether you will get seat in IIT or not, okay, or whether you get seat in Ananesti or not. Okay, so if I'm taking an individual sample, I can able to say, yeah, you can able to get the seat, or you may not be able to get the seat. So these things I can able to say. But if I'm connecting with a huge amount of data of around 1 lakh student data, practically it's hard for me to connect. So for that only we are connecting with the supervised learning. So if I'm taking a single sample, I can able to identify it. If I am taking a huge number of samples, it's hard to identify it. Okay. Why I am saying this means I'll explain some basic ideology of ML and basic ideology of DL. Then I'll come back to that object recognition. Okay. So this is supervised way. Unsupervised, it's a purely categorical way. Okay. It does not have a known outcome. Okay. So it's purely based on that developer perspective. Okay. How he is thinking. So that's what about the unsupervised learning it is. Okay. So I think you got it. What is supervised and unsupervised? So here I'll show. If you are in the position to understand this slide, I'm sure that you are capable to understand what is ML, what is DL, and what is AI also. Okay. So here I'm connecting data with answers. In the previous example, in the image present demo, I shown different data, the Renaissance board and every development boards. I shown those development board corresponding with the label. I mean data with answers. So those these things are all data. I connected with the label. Okay. So I'm connected to the model. Okay. Once I'm connected to the model means this model is having the mathematical capability. This model is purely having the mathematical capability. Based on this mathematical capability, okay, based on this data set, both are combined together. So I'm going to train it. Once it is trained, a new model is created. Okay, this a new model is created. Okay, once the new model is created, okay, this new model purely works on these data, the data which I trained. Okay, this is the generic mathematical structure. Okay, if I'm connected to the a new model is created, and even if I'm connecting data without answers, this new model, I mean the test data. Okay, here these data are all trained data. These data are all test data. Even if I'm connecting with the test data, so it automatically identifies and accepts it, and it does the necessary action. So that's what about the predicting mechanism. So even you might have seen those demos also. Okay, how these things are all works. Okay, everything you might have seen it. Okay, so based on this prediction methodology only, everything works in a clear way. Okay, so that's what I shown in the demos. Okay, even I can show the movie data with revenue. This is the exact one. This is the labeled data and connected to the model with the CNN algorithm. So once this is trained, new model which is the combination of this mathematical model and the data. So this model works for our data only. So if I'm connecting some unlabeled data, this model identifies and predicts under which label it is. So this ML works. Okay, now I'll connect with some DL also. So, so I'm connecting with the DL. If I'm connecting with the DL, practically this DL will have different layers. One is the input layer, another one is the hidden layer, third one is the output layer. Three different layers are there. Okay, based on these three different layers only, we'll be focusing and we'll work. Okay, so here what I am trying to say means, okay, these are the three different layers. The light blue are all input layer, these orange color are all hidden layer, and dark blue are all output layer. If I'm going to train, I mean, let's assume, not as assumption, okay, this is the basic logic. This everything works based on the human brain only. This everything clearly works based on the human brain only. Okay. So whenever I'm connecting some data or some logical operations, okay. So this purely work based on the neural which having in our brain. Okay. So let's assume I'm going to give my hand. I'm going to give handshake to one of our participants. Subramanian. Okay, so if I'm giving my hand to Subramanian, let's assume the Ganesh Kumar is going to see this. From I'm giving my hand to Subramanian. Okay, and also he is replying that he is giving hand to me. So this how that Ganesh can able to be. Whereas in our cases, okay, the Ganesh can able to see the input layer and output layer. The input layer is I gave my hand to him, okay, and he gave the output is he gave his hand to me. So that's what the Ganesh has seen. But whereas what happened in between these things? So once I gave my hand, okay, to Subramani or Subramani. So if I looks dirty, practically he won't give his hand to me. If I looks dirty, practically he won't give his hand to me. Okay. So, and even if I got affected with COVID-19, again practically he won't give his hand to me. Okay. These are all the basic logics that works in your brain. Okay. Based on that logic only, we are connecting it. Based on that logic only, we are connecting to that. Okay. So in between these scenarios, lots of logic will be connected. Whether I looks dirty, whether I got affected with COVID, whether I am the known person, even if I am known person, whether already I took fight with him. So multiple logics will work in his brain. Okay, then only Subramaniam will give his hand to me. Okay, so lots of logic. These things are all hidden layers. These logic are all purely hidden layers. Okay, so based on this only, it clearly works and it does the necessary process. Okay, so here what happens means this how the neural network structure is there. Okay, from others perspective, input and output only. Hidden layer we can't see that, but hidden layer we have to feel it. So here each and every process is having a different hidden layers. Okay, based on this hidden layer, how these gets work. So everything we can able to calculate it. So that's what I'm trying to say it here. Okay. So I'm taking a one sample neuron connecting to this. Okay. So in this, I'm having an activation function. These are the this is the input, but it can be directly from input or it is from the previous layer also. Okay, like this. The data from the previous layer, the form of a computation transforms inputs. Okay, this is the neuron output that can be transformed to output and also fed to the some other neuron also. It can be anything. Okay, and let's assume I'm having the input as x1, x2, x3. Okay, and corresponding weightages is nothing but a W1, W2, W3. Okay, 1 minute, please. One minute, 1 minute. Yeah, so fine. So the input is x1, x2, x3, and corresponding weightage is w1, w2, w3. Practically, I can able to say the input is nothing but x1, w1 plus x2, w2 plus x3, w3. Okay, and which is fed to the corresponding function. Okay, so if that's the case, okay, practically what happens means here we are having that mechanism like so whenever I'm giving a input, it has a different outcome thought process. Okay, so here there may be some small error. Okay, for that I'm connecting a bias called B. So that's what it changes to x1 w1 plus x2 w2 plus x3 w3 plus B. This is the input. Okay, here you can able to see it. So that's what I'm showing. Is nothing but a z is nothing but a x1 w1 plus x2 w2 and x3 w3 plus B. Okay, so this is the input z. Okay, and the output f of z will be, I mean, actually this is not a z transform. So input is z, output is f of z. Even if I'm making a as an input, a equal to x1 w1 plus x2 w2 plus x3 w3 plus b equal to b. If I fed after the function, this might be a f of a. If it is m, if it is f of m, it's not a z transform. Okay, this is function. In function can be anything, any logic, any mathematical computation. Okay, so likewise. Okay, so here this is from the basic mathematical notation. Okay, so how these things are all connected. Okay, so I think you can able to identify what it is and how it is. Okay, so now I can able to connect with the thing called the presentation, which is from the slide. Okay, I can able to connect those things also to you now. Yeah. So I think you got some understanding about what is ML and what is DL, how these things are all working. Okay, how it can be processed. So you got some basic idea. Okay, so I think once you got those ideas, now it's advisable to understand and what it is and how these things are all, these things can work. So these things you can able to identify it. Okay, so if I'm connecting with that computer vision task, okay, practically it's a hard to distinguish between the different related the computer vision task. For example, the image classification is a straightforward, but the difference between object localization and object detection can be a confusing one, especially when all three tasks must be just be equally referred as object recognition. Okay, practically the image classification involves assigning a class label to an image, whereas the object localization involves a drawing and bounding box around one or more objects in an image, and the object detection is more challenging and combines these two tasks and draws a bounding box around each object of interest in the image and assign them a class label. Together, we can say all these problems are referred as object recognition only. Okay, so after this, I mean, you can able to understand how the object recognition is refers to a collection of related tasks to identify the objects in a digital photographs and regional based convolution neural networks. Okay, addressing the object localization and recognition task, designing for the model performance. Okay, and YOLO is a second family technique for object recognition. Okay, so these things you can able to understand. Okay, so again, I'm just giving a basic idea. Object recognition is a general term to describe a collection of related computer vision tasks that involve identifying the objects in the digital photographs only. Image classification involves predicting the classes of one object in an image. The object localization practically refers identifying the location of one or more objects in an image and drawing a bounding box around their extent also. Whereas the object detection combines these two tasks and localize the classifies and one or more objects in an image. Whereas if I'm connecting with the image classification, which will predict the type of the class, which type are the classes of an image. Okay, an image which a single object such as a photograph, these things you can able to identify it. Whereas the output practically refers to a class label also. Okay, whereas in object localization, it will locate the presence of object in an image and indicate their localization with the bounding box. Here, the input can be an image with one or more objects, such as a photograph. The output can be one or more bounding boxes. Whereas in object detection, which will locate the presence of object with the bounding box and types of the classes of located objects in an image. Practically, here also the input can be an image with one or more object. Output can be one or more bounding boxes, which is defined by a point with height and class label for each bounding box. Okay, so further extension to this breakdown of a computer vision task is object segmentation. Okay, also called object instance segmentation or semantic segmentation, where this instance of recognized objects are indicated by highlighting the specific pixel of the image instead of a coarse bounding box. So based on this, here I can show this. Yeah, the object recognition, the image classification, the object location, detection, object segmentation. So most of the recent innovation in image recognition problem have come as a part of the participation in ILSVRC task. So practically ILSVRC means ImageNet Large Scale Visual Recognition Challenge. Okay, practically what that does means that ImageNet Large Scale Visual Recognition Challenge evaluates the algorithm for object detection and image classification at the large scale. Okay. One high-level motivation is to allow the researchers to compare. I mean, this is purely for research purpose. Okay. So if you are focusing for large-scale data, so you can able to connect these things. Even in Kaggle, lots of ILSVRC dataset is there. Okay. So practically you can able to connect with the different classifier error, whereas in the classifier result in 2010 and today is entirely different. The classifier result in 2010 and today is entirely different. Practically ImageNet is a data set of around 15 million labeled high resolution images Okay, roughly around 22,000 categories. The images were collected from the web and labeled by human labeler by using like the Amazon mechanical track crowdsourcing tool. Like different tools are there. Okay, so starting from 2010, the Pascal Visual Object Challenge has an connecting with ILSVRC. Okay, ILSVRC use the subnet of the ImageNet, which is roughly around 1,000 images in each 1,000 category. In all this, around 1.2 million training images validated with around 50,000 images, and also around 1.5 lakhs of testing images also. Okay, like this, it connects. Okay, so based on that only it works. So that's what I'm trying to say. ILSVRC is a advisable methodology where the ImageNet dataset is a very large collection of human unedited photographs designed by some computer vision algorithms. Okay, and also which is design and development benchmarking with the state of art algorithm, and so different methods are there. So in this also we can able to say the image net data set. I mean three categories. Another one is a image net large scale data visualization recognition challenge, and the third one is we can say deep learning milestone from ILSVRC. Okay, I'll explain this detail in after completing some uh, algos. Okay, so in this image classification, okay, algorithm it's produce an object of present in an image, whereas the location. I mean already I explained right, the image classification, localization, and object detection. Okay. So here you can able to see some images. Okay. So in this, practically the first thing is the object, single object localization, then object detection. If it is a single object localization, practically the algorithm produces a list of object categories present in the image along with an axis aligned bounding box indicating the position and scale of one instance of each object category. Whereas in object detection, algorithm produces a list of object category present in the image along with the axis aligned boundary boxes indicating the position and scale of every instance of each category. Okay, practically we can see that the single object localization is a very simpler version of more broadly defined, whereas the object localization constraining the localization task objects to one type within an image, which may assume the easier task. Okay, this picture purely works under the ILSVRC. Okay, so the performance of a model of image classification is evaluated using a mean classification error across the predicted class labels. The performance of a model for single object localization is evaluated using a distance between the expected and we can say the predicted bounding box also for expected class, whereas the performance of a model for object recognition is evaluated using the precision and recall across each of the best matching bounding boxes for the known objects in the images also. So now we can be familiar with the problem of object localization and can be the detection also. Okay, so we can connect with the different algo RCNN. Before that RCNN, I just explained about the CNN algo. Then I'll connect with the RCNN. So,
Participant, kindly please wait. I think sir is having some network issue. He'll be back.
Sorry, the power is disconnected. Sorry.
It's okay, sir. Carry on.
Power went off. So I connected with my hotspot. So I'll share my screen again. Yeah. 1 minute. Yeah. So I'm connecting with the methodology for CNN algo. Okay. So how this convolution neural network works. So I'm connecting that way. Okay. How this convolution neural network works. So in this CNN, this is purely for this is purely an scalar works under the scalar unit, whereas EANN is artificial neural network that purely works under the vector unit. Okay, which connects with the image and connects with the process. So let's assume uh, I'm going to consider. Assume I'm going to take a image. So I'm going to take a sample of images, this one, copy image. So this is the actual images, but if I'm connecting via the thread, okay, and cutting like this in a vertical way to all these images. So this is a odd one, this is a even piece, odd piece, even piece continuously. So then if I connect only the odd piece together and even piece together, then the image may looks like this, the image maybe looks like this. Yeah. So if again I'm connecting this image in a horizontal way, okay, the image maybe looks like this. Okay. So here practically this images compresses and this can be detected. Okay, so I just connected with the four quadrants. So even if I'm cutting pieces into 16 pieces, 16 way, this is a four. I mean the ratio of 1:4. If I'm connecting with the ratio of 1:32 also, it can able to identify how the images and how it is. So these things can be recognized. So for this case, I'm going to show with the CNN. So whenever I'm connecting CNN, I'll go. Okay, I'm not going to take. That's the same. If I'm having a images, practically if I'm having images, this is matrix. Okay, let's assume I'm having an image. Let's assume this is the image, but this is a combination of some rows and columns. Okay, so each cell will have some values. Okay, and under that value, what's the number that I'm having? So that number only shows as a color, like let's assume. So this is a 1 pixel. Okay, so like this, everything will have. Okay, so what's the number it is? So that number will be considered as a color of the image, color of that particular position. Okay. So here I'm having some inputs, I'm having some kernels. So let's say I'm having an image of 3x3 size. I'm having this 3 size. Okay. In this 3x3, so I'm having a different color, like a 3, 2, 1, 1, 2, 3, 1, 1, 1. So I'm going to place a kernel over the input image. So if I'm taking this kernel and placing over that input layer, practically I'm going to do the dot products. I mean like this. So practically I will be doing the dot product of 3 into -1 plus 2 into 0 plus 1 into 1 plus 1 into -2 plus 2 into 0 plus 3 into 2 plus 1 into -1 plus 0 into 1 and 1 into 1. So practically I will get the value as 2. And then I will get the value of 2. So here I am doing the dot products. Here I am not doing any vector products. Okay, if it is a vector, that's a purely ANN. That's a different case. Okay. So I'm connecting this kernel. The kernel can be another name for kernel can be it's a filter. Okay, the kernel can be filter. Okay, so the kernel can be a vertical line decoder, horizontal line decoder, corner director. Different kernels are there. The objective of the research is to update that how this kernel works. Okay, how these kernels are all connected. So likewise, that objective of the kernel will be there. So if we are doing the research, your main objective is to connect how this kernel are connected. Okay, how this kernel are connected together such a way that it will have a advisable result. So likewise, okay, if I'm connecting a convolution network like this, okay. So here I'm having a matrix large 5 cross 5 and the kernel is a 3 cross 3. So by basic, the formula is this is a m row n column and this is a n row n column. Then practically the output will be m minus n plus 1. 5 minus 3 plus 1 is nothing but 3. The output will be 3. Okay. So that's how this convolution process is connected. So here I'm having 5 minus 3 plus 1 is nothing but a 3 cross 3. This is the output. So even I can show some GIF images also. How this can be performed. Yeah. By seeing the GIF image, you can able to understand it easily. How these things are working. Okay, even I can show another GIF image. like this also it works. So at the top is the output. Here it's connecting with the padding. Now I connect with the logic again. Okay. So here I'm having some convolutions methodologies. So input can be a different size. Okay. So if I'm doing for this matrix, this is around 5 cross 5 matrix and connected to the kernel of a 3 cross 3 matrix, I can able to connect the output. But whereas if I'm connecting, so this midpoint is considered here and these edges are all not considered for the better valuation. So for us, if we need for the edges connection also, we can able to perform with the padding mechanism. We can able to perform with the padding mechanism. Okay, so I can able to add one row at the top and one row at the bottom, and also I can able to add one column at the right and one column at the left for this matrix. Okay, like this I can able to add. So practically I added one row at the top and one row at the bottom, one column at the left and one column at the right. So practically now this is nothing but a 7 cross 7 matrix. Okay, this midpoint also is considered. So previously it was in the edge, now it's not in the edge, this is on the mid part. Okay, this also will be considered in a clearly. Okay, so in this m is nothing but 7, n is nothing but 3, 7 minus 3 plus 1 is nothing but a 5, the output is 5 cross 5. This mechanism or these things also is working. I mean that CNN algorithm, how this CNN algorithm is also is working. Okay, so based on this only we can able to get some. Sorry, 1 minute, 1 minute. Okay, so this is with padding. Okay, so you can able to understand how this works under the padding mechanism. Okay, so this is about the CNN algo. Okay, so even I can able to explain about the RCNN. Okay, so I can come to that slide and I will explain about the RCNN. So if I'm connecting with the RCN, practically RCNN refers to region-based convolution neural network, and which is developed by someone called Rose. I mean, I forgot his name actually. Okay, this includes the technique called RCNN, faster RCNN. Okay, so RCNN. It may have been one of the first large and successful application convolution neural network to the problem of object localization, deduction, and segmentation. The approach was demonstrated on a benchmark of the dataset, okay, achieving the state of art of results on the BOC 212 dataset and also 200 class ILSVRC 2013 object detection datasets also. It has 3 different model. Okay, practically the model 1 is the region proposal, generate and extract the category independent regional proposal like candidate bounding boxes example. Okay, another one is a feature extractor, extract the features from each candidate region using a deep convolution neural network, and the classifier. The classifier classify the features as one of the known classes like linear SVM classifier model. Practically, the architecture of the model is summarized in a different way. We can able to see these images also. Here, the input images is given, and extract region we can identify. Okay, so different regional based things are all identified, and which connects to the CNN features. CNN, I mean, from that CNN features, we can able to connect whether this is a person or what is these things. Each and every region basics is connected to the CNN and it classifies accordingly. So practically the computer vision technique is to propose the candidate region bounding boxes of a potential object in image called selective search. Although the flexible of the design allows the other region proposal algorithm to be used also. The feature extractor used by the model for AlexNet Deep CNN also connected in ILSVRC images. The output of the CNN was around I think so, it's 4096 element vector that describe the content of the image that fit into even it can be connected with the linear SVM of the classifier and especially one SVM trained for each known classes. Practically, it's a relatively simple and straightforward application of the CNN to the problem of the object localization and recognition also. A downside of the approach is that it's a slow and it requires the CNN based feature extraction pass on each of the candidate region generated by the proposal algo. This problem approximately connected to 2000 proposed region per image asset test time. Okay. Whereas if I'm connecting the fast RCNN, okay, so the fast RCNN leaves the limitation of the RCNN, okay, which can be connected in a 3 different ways here also. Training is a multi-stage pipeline. Training is expensive in space and time. Object detection is slow. Okay. Practically, in training is a multiple stage line involves the preparation and operation of 3 separate models. And whereas in training, it's expensive in space and time. The training a deep CNN on so many region proposal per image is very slow. Okay, the object detection is slow. Make perfection using a deep CNN. So many region proposal are very slow. So the fast CNN is proposed a single model instead of a pipeline to learn output region and classification directly. Practically, the architecture of the model takes the photograph a set of region proposal as input that are passed through a deep CNN. A pre-tamed CNN, such as we can say like BGG also, BGG16, which is used for feature extraction. The end of deep CNN is a customer layer called region of interest pooling layer. So generally you will be saying ROI pooling that extract the features for a given input candidate region. The output of the CNN is then interpreted by a fully connected layer. Then the model bifurcates into 2 different output. One for the class prediction via the softmax layer, another with the linear output for bounding the boxes. The process is then repeated multiple times for each region interested in a given. I mean, you can say with this images also. Okay, so here ROI protection is to this deep sea network also is connected. Based on that ROI pooling, okay, a region of interest pooling layer, so it connects to the softmax and the necessary B-box regressor, and it gives the, so this is how the fast RCN works. Whereas connecting to the faster RCN, okay, connecting to the faster RCN, the architecture was basics for first places result in IL ESP as 2015 also, and also in COCO 2015 also. The architecture practically designed to both propose and refine image proposal. Okay, so and the training process is referred to as R region proposal network. Generally, we will be saying RPN. So these regions are used to concentrate with the fast RCNN model in a single model design. These increments both reduce the number of region proposal and accelerate the test time operation of the model to near time within the state of art of the performance. Practically, the RPN is nothing but a convolution for proposing the region and type to consider in the region. Whereas fast RCNN is a convolution neural network for extracting the feature from the proposed region and outputting the bounding box and the class label. Practically both model operates on the same output of the deep CNN. Okay, so which is proposed the deep CNN. The region proposed network act as a attention mechanism for fast RCNN. Okay, informing that the second network of where to look or pay attention. The aperture of the model is shown in the images also. The convolution layer, the feature maps, so connecting to the RPN, ROI coding, and connects to the classifier. It does the process. So practically, the RPN works by taking the output of the pre-trained deep CNN. Okay. Connecting to VGG16 also and passing a small network over the feature map and outputting the multiple region proposal and class prediction for each region proposal and bounding boxes. Based on the anchor boxes are pre-daily shape designed to accelerate improve the proposal of region. The class prediction is binary practically, indicating the presence of an object or not so-called objectness of the proposed region. The procedure of alternating the training is used whether both subnetworks are trained at the same time, although the interleaved that allows the parameter in the future detector deep CNN to be tailored. Okay, at the time of writing this faster RCNN architecture is a pinnacle of the family of the model and continues the actually a state of art of builds upon the object recognition task. So even another method called the YOLO. Okay. So YOLO means you only look once. YOLO means you only look once. Practically the RCNN model may be generated more accurate, yet the YOLO family models are much faster than RCNN. Okay. Particularly which can connect with the real-time decryption also. YOLO model approach involves a single neural network trained end-to-end that takes photograph as an input. Okay, here also you can able to see a dog and a cycle and a car in the image. Okay. And predicting the bounding boxes and class label for each bounding boxes directly. The technique offers lower predictive accuracy, although operates 45 frames per second up to 155 frames per second for a speed optimization version of the model also. Okay. Practically, YOLO model process images in a real time as 45 frames per second. Fast YOLO process is around 155 frames. The model works by first splitting the input images into a grid of cells. So that's what you are seeing here. I can, yeah, here it splits the model and with a grid of cells. Okay, where each cell is responsible for predicting a bounding boxes. Okay, if the center of a bounding boxes falls within it, each grid cell predicts a bounding boxes involving the XY coordinates and width, height, and the confidence. Yeah, class prediction is also based on the each cell. Okay, you can able to say an image might be divided into 7x7. Okay, grade. Each cell in the grade may predict 2 bounding boxes, resulting in different proposed bounding boxes prediction. So totally in this around 94 bounding boxes are there. Okay, so in this the class probability makes that bounding boxes with the confidence that then combined with the final set of bounding boxes and place label and image taken from the is connected with the 3 different direction. Here you can able to see this bounding boxes will have a gold color. So multiple times this is bounded, and also here also you can able to see the multiple bounding boxes. And also here also you might have seen the dark bounding boxes. It took based on the tablets, it took how many bounding boxes are all connected. So then only the final direction is made, and it says these are all 3 different bounding boxes are processed. Okay, whereas even the YOLO version 2, version 3, also is there. Okay, whereas which is capable of handling the YOLO 9000. Okay, so that can able to predict 9,000 object classes in a single images also. Like a faster RCN and OLO V2 model makes use of anchor boxes, predefined bounding boxes with useful shapes and size and tailored during training. Okay, the choices of bounding boxes for an image is pre-processed using the different clustering mechanisms like k-means analysis on the training data sets also we can able to do. Practically, we can predict the representation of the bounding boxes is changed to allow the small changes have less dramatic effect on the prediction, resulting in a more stable model rather than predicting position and size directly. Offsets are predicting for moving and reshaping the predefined anchor boxes relatively to the grid cells and lambda by and logistic functions like this. Okay. So how these logistic functions are all performance, how these things are all processed. So this process is there. So I think you got some idea about what it is and how it is. Okay. So I think if you are having a doubt, okay, please connect me. I can able to explain. So this is how that YOLO version 2, version 3 is working. Okay, so this is about that even I'm having the mobile net only. So even in the during afternoon session, I'll show some more demo because the Wi-Fi works. Those traffic will be different. This speed is different. So I can use some more demos also. Okay, how these object recognition are helpful and how these things are used and even while connecting to the pattern recognition, okay, how this pattern recognition take and how it is connected to the time series analysis. Okay, based on the time series, how that business cases can be done in a perfect manner. So these things are all we can able to see in afternoon session. So I think you got some idea about the object recognition, the different algorithm. Even I showed those demo also. Okay, with some Python. Okay, if you're having doubt, please I can able to help you out, or we can meet after the lunch. Hello.
Yeah, thank you so much, sir. If you have any doubts, you can unmute your ask or else post your question in the chat box.
Yeah, sure. So if you're having doubt, you can post or you can post lunch also. It's up to you. I can able to explain in a object recognition in a different way.
Okay, so I think there is no any kind of doubts on side of participants, sir.
Okay.
Because it was very informative and interactive because using a simple paint tool that we have used and explained the concept, it was very towards the session. And on behalf of Department of Engineering Technology, we would like to give you a token of appreciation and gratitude, a virtual memento that we would like to present. Kindly accept it, sir.
Yeah, sure, man.
Thank you so much for
Yeah, thank you, thank you. Thank you.
and participants. Feedback